Hello. Okay, so if everyone can turn to page 8 in their packet, we're going to take a look at a bunch of examples today. So the first example, number 4, the directions say to write an equation for each of the following trig functions. Now, we know that this is the general setup of our equation for a sine curve, and same thing for a cosine curve, except instead of the word sine being here, we would have cosine. All right, so the number in front of the word sine or cosine is the amplitude, and the number in front of the x would be your frequency. All right, so for each of these, let's first write down what our amplitude and what our frequency is, and then we'll plug it in to this equation. Okay, so at this point, right, our graphs are pretty straightforward. We don't have any graphs that are shifting up and down. So in order to find the amplitude just means the height from the midline. For all these examples we're going to do today, the midline is just your x-axis. Isn't that the middle height of this graph? So from this middle height of the graph, don't we go up 3 units as well as down 3 units, right? So the height of this curve would be 3. It's the height from the middle of the graph. So the amplitude would be 3. Now the frequency is the number of complete cycles between 0 and 2 pi. So we could see here this is a sine curve, right? Sine is starting at 0, 0, and if it's a positive sine curve, it goes up, down, up. Whereas if it was a negative sine curve, look at number 6. This is a negative sine curve, right? See how it's going down, up, down? Okay, so basically we have 1 complete sine curve, 2 complete sine curves between 0 and 2 pi. So that means our frequency would be 2. All right, so all we have to do is take the 3 and put it in front of the word sine, and the 2 and put it in front of the x, and we have our equation. All right, so there we have it. So y equals 3 sine of 2x. All right, so let's take a look at number 5. Now in number 5, let me just move this over a little, we could see here that this is a cosine curve, right? It's starting at its maximum, dropping down to the minimum, and ending back off at the maximum. So this is a positive cosine curve this time. All right, so here, right, it follows the same format as if it was sine. The number in front of the cosine is your amplitude, and the number in front of the x is your frequency. All right, so here, let's find our amplitude. So if this is the middle height of our graph, right, the x-axis, the amplitude is the height from the midline, so 1, 2. So the amplitude would be 2. The frequency we know is the number of complete cycles, right? Frequency means how many. So it's the number of complete cycles between 0 and 2 pi. So if we look here, isn't this 1 complete cosine curve between 0 and 2 pi? So the frequency would be 1. So now all we have to do is just replace the a with a 2 and the b with a 1, which technically 1x is the same thing as x. So if you just want to write, instead of 1x, if you want to write x, that's fine. And you could put parentheses around this x, or since it's really just a 1 in front of it, you don't need it. So this is fine, or if you prefer to put the parentheses, you can as well. All right, so what I'd like you to do now is I'd like you to try some of these on your own. So why don't you try numbers 6 through 11 on your own, hit pause, and then you can hit play when you're all done and see how you did. All right, so if we take a look here at number 6, now the amplitude, here's our midline, right, the x-axis, the height from the midline is 3 units. We go up 3 as well as down 3. So the amplitude is going to be 3. That's our height. Now, this is a sine curve, right, because it's starting at the midline, it's starting at the middle height, it's starting at 0, 0. And even though it's going down first before it goes up, right, we know it's a negative sine curve, but please do not make your amplitude, if you're writing this out, do not say that we have a negative amplitude. We don't. Okay, the amplitude always has to be a positive number. The amplitude is 3. The negative comes into play when we go to write out the equation. All right, so the frequency is the number of complete cycles between 0 and 2 pi. So you could see we have 1 complete sine curve between 0 and 2 pi. So the frequency is 1. All right, so when we go to write out our equation, we could write y equals. Now remember, this is a negative sine curve because it's going down first instead of up first. So this is where the negative comes into play with our equation. Then we put the amplitude, then we write sine of the frequency in front of the x, so sine of 1x, or you could just write x. So that would be your equation for this one. All right, number 7. So number 7, we again have a sine curve, right? It's starting at the midline. If it starts high or starts low, it's cosine. But if it's starting at the midline, it's sine. And this is a positive sine curve because it's going up first. So far we're going to have y equals positive sine, and I'm going to leave a space because we have to put the amplitude in front of that. Now let's look at our amplitude, okay? So our amplitude is the height from the midline. So here we're only going up to a height of 1/2. So our amplitude is 1/2. Or you can write 0.5 if you want. Oh, let me stick with pink. So that is going to go in front, the amplitude goes in front of the word sine. Now the frequency is the number of complete cycles between 0 and 2 pi. So we have 1, 2 complete cycles. So the frequency is going to be 2. So that is the number that we're going to put in front of our x in our equation here. All right, so this is our equation for number 7. All right, number 8. So let me just fill out the amplitude and frequency. So the amplitude would be 2, right? The height from the midline is 2 units. So that is 2. Now the frequency. We could see here that this is a cosine curve, right? It's starting up high on the y-axis, and then it's dropping down low. Now, between 0 and 2 pi, isn't this just the first half of a cosine curve, right? We would need to keep going to finish it off. So from 0 to 2 pi, from here to here, this is only half of a cosine curve. So my frequency would be 1/2. So when I go to write the equation, we'll have y equals the amplitude, which is 2, times cosine of the frequency, which is 1/2, in front of our x. Sorry, my pen didn't come out the best there. Now, keep in mind, the reason why this is positive is because cosine, if it starts high and drops low, right? If it starts off high, that means it's a positive cosine curve, so this is going to be positive. Whereas actually, perfect, look at number 9. Number 9 is starting down at a minimum. When it starts at a minimum, we know it's going to be a negative cosine curve. So I'm going to start off this equation as y equals negative something. All right, so let's look at what we have here. Our amplitude is positive 2, right? It goes up to a height of 2 from the midline. And then the frequency, the number of complete cosine curves between 0 and 2 pi, is 1, 2, right? That's 2 upside down cosine curves, so the frequency would be 2. So let's go back to our equation now. So we already have y equals negative, because it's a negative cosine curve. So then it would be 2 cosine of the frequency, which is 2 in front of the x, so 2x. So that is our equation. All right, number 10. Now, number 10, we could see we have a cosine curve here, right? Starting high, dropping low, coming back up. So this is a positive cosine curve. All right, now, the amplitude, the height from the midline is 1, 2 units, so the amplitude is 2. Okay, so now the frequency may have been a little tricky. The frequency is the number of complete cycles between 0 and 2 pi. So this is going to 2 pi over 3. We want it to go to 2 pi. Now, some of you may have realized in front of the pi, there's a 2/3, and isn't 2/3 plus 2/3 plus 2/3 6/3, which simplifies to 2 with this little pi there. So basically, if one cycle occurs in 2 pi over 3 units, we would need 1, 2, 3 of those cycles to get us to 2 pi. Now, honestly, I personally think that may be a little confusing for a lot of you guys. So if you understood that, great. If you did not, don't worry about it. I'm going to erase that because I think that may be a little tricky to think about it that way. Now let's think about another way we could do it, right? We know a formula. Isn't the frequency equal to 2 pi over the period? Now let's think about this. 2 pi over the period, right? The period is the horizontal length of one complete cycle. So doesn't it take us 2 pi over 3 units to complete this cycle? So that would be your period, right? So we can replace the word period with 2 pi over 3. Okay, so what's going to happen is this pi on top cancels with the pi on bottom. And you could, I mean, technically, I guess in your calculator, if you wanted, you could plug in 2 divided by 2/3. But I'm going to do this by hand. If you're dividing by a fraction, we do keep, change, flip. We keep the numerator, we keep the 2. We change division to multiplication. And we flip the second fraction upside down. Okay, you may remember this from middle school. If you're dividing by a fraction, you do keep, change, flip. You keep what's on top, you change the division to multiplication, and you flip this upside down. All right, so now, if I were to multiply these together, right, you could do one of two things. Either the 2 on top cancels with the 2 on bottom, just leaving you with 3 over 1, which is 3. Or you could say if I multiply across, it leaves me with 6 over 2. And isn't 6 divided by 2 just 3? So either way, we get the frequency to be 3. Okay, so now we can just substitute our information into our equation. So it's going to be y equals, this is a positive cosine curve, so positive 2 cosine, and since the frequency is 3, it's going to be 3x, just like that. So that one was a little tricky, but we're going to see others like that as we go, where if you use this formula, it's not going to be so bad. Okay, and then finally, I asked you guys to try out number 11 as well. So let me just write this down, the amplitude and the frequency. Okay, so we can see in number 11 that it's a negative cosine curve, right? It's starting at a minimum. If it starts at a minimum, it's a negative cosine curve. So y equals negative, and I'm going to leave room to put the amplitude in front of the word cosine. All right, so the amplitude is the height from the midline, which is 1, 2 units. So our amplitude is 2. Oops, so let me put that right there. Here, I want to keep this pink, right? Color code everything. The frequency is the number of complete cycles between 0 and 2 pi. So we have 1, 2, 3 cycles. So the frequency is 3. So that's what we can put in front of the x in our equation. All right, so 11 I think personally I think that was a little easier than number 10. All right, now we're going to take a look at some of the ones on the bottom. And I think I'm going to do the first one with you, and then I'm going to have you try some of the rest on your own. All right, so if you take a look at number 12, right, we can see this is a sine curve, right? It's starting at the midline, starting at 0, 0, it's going up, down, and back up. So this is a positive sine curve. So y equals, I'll leave room for the amplitude, but positive and then sine. Okay, so now the amplitude is our height from the midline. So how high does this go up? Well, we could see, look, it goes up to a height of 30 units. So our amplitude is going to be 30. All right, so I could slide that in here. Now we know the frequency is the number of complete cycles between 0 and 2 pi. So in this case, look at our x-axis. It's not in terms of pi. It's in terms of numbers. So if it's in terms of numbers, let's go back. Let's think about what we did in number 10. Look back at what we did in number 10. Didn't we just use our formula? We said the frequency is equal to 2 pi over the period. So that's going to be equal to 2 pi over, now the period, remember, is the horizontal length of one complete cycle. So how long horizontally does it take to complete one cycle? Well, look at that. We took 32 units to complete one sine curve. So I'm going to replace the period with 32. And then remember, when you have a fraction, you always want to simplify. So to simplify this, just simplify 2 over 32. Doesn't 2 over 32 simplify to 1 over 16? So this would simplify to 1 pi over 16, which usually we just write as pi over 16. Okay, so this is our frequency. So this is what's going to go in front of the x in the equation. that in a parenthesis with an x. So I just want to point out that when your x-axis is in terms of numbers, you're going to have a pi as your frequency. When your x-axis is in terms of pi, you're going to have just a number as your frequency. All right, so what I'd like you to do right now is I'd like you to try out numbers, basically the rest of the examples on this page and the next. So numbers 13 through 17. And hit pause, try them out, and then you can hit play and see how you did. All right, so let's start at number 13. Now 13, we can see right here we have a positive cosine curve, right? It's starting off at a max, dropping all the way down to a min, and ending off at a max, okay? If it starts off at a max, it's a positive cosine curve. Now the amplitude, our height from the midline, is 3 units, okay? We go up to positive 3. Now the frequency, we can't tell how many complete cycles there are between 0 and 2 pi because this is in terms of numbers. So we're going to just use our formula. We know the frequency is equal to 2 pi over our period. All right, so that's going to be 2 pi over, now the period is the horizontal length of one complete cycle. So isn't this one complete cosine curve, right? And it takes 320 units to get there. All right, so it's supposed to be an equal sign. I kind of blended in with that. All right, so since 2 over 320 simplifies to 1 over 160, this is going to be 1 pi over 160. Or even better, just pi over 160. So that is our frequency. All right, so let's write our equation. So we have y equals positive 3 cosine of pi over 160, and don't forget that x. And there we have it. All right, so I hope everyone got that one right. All right, the next one, number 14. Now here we could see we have a negative sine curve. It's starting at the midline, so it's sine, but because it's going down before it goes up, it's going to be a negative sine curve. All right, let me write that. Y equals negative, and then I'll just leave a space to put the amplitude in front of the word sine. All right, so our amplitude, the height from the midline here, and let's see, it goes up to a height of, let's follow that over, 300. So here our amplitude is 300. All right, might as well just slide that. I hope I left myself enough room, but I might as well slide that 300 right there. All right, now we don't know the frequency by just looking at it, but again, let's use our formula. The frequency is equal to 2 pi over the period. Now, I hope no one was tricked. The period is not 32. The period is the horizontal length of one complete sine curve. Isn't from here, right? You're going from 1, 2, 3, 4, these 5 points. Isn't this, right, all the way down, all the way up, and back at the midline? Isn't this one complete cycle? So that takes 16 units to get there. All right, so our period is going to be 16. And then since 2 over 16 simplifies to 1/8, this simplifies to 1 pi over 8, which is just pi over 8. All right, so let's put that in a parenthesis in front of an x, and that right there is our equation for number 14. All right, so number 15. Now here we have a negative cosine curve, right? It's starting at a minimum, so you know it's going to be a negative cosine curve. Cosine either starts at a minimum or a maximum. When it starts at a minimum, it's a negative cosine curve. All right, so our amplitude, the height from the midline, the highest point it goes from the midline is 40, so that's going to be our amplitude. And we know our frequency, let's use our formula here, is 2 pi over the period. So the period, the horizontal length of one complete cosine curve is, in this case, 32 units. Okay, so this is going to simplify to 1 pi over 16. All right, so let's slide it in the equation. So y equals, we said it was a negative cosine curve. The amplitude is 40, so let's put a 40 in front of the word cosine. And then since our frequency is pi over 16, we're going to put that in front of the x. And there we go. All right, number 16. So here, our amplitude, right, the height from the midline is 60 units. All right, the frequency. The frequency is not going to be this last number over here. It's the horizontal length of one complete cycle. Now, isn't this one complete sine cycle, and it stops right there at 40? So the period is going to be 40. So this is 2 pi over 40, which that fraction simplifies to pi over 20. All right, so the equation would be y equals, it's a positive sine curve. We know that sine starts at on the midline. So here we have y equals positive 60 sine of pi over 20x. And then finally, the last one. So with this one, our amplitude, the height from the midline, is 1. Now the frequency is 2 pi over the period. Now be careful. The period is not 1/3. Isn't that just half of a sine curve, right? We'd have to finish it off. And when we finish it off, if it takes 1/3 units to get here, wouldn't we be at 2/3 when we finish? So the period is 2/3. Now, if you want, you could plug in your calculator 2 divided by 2/3. I'm a fan of doing it by hand. So remember, we could do keep, change, flip. We keep what's on top of the fraction. Oh, actually, there's a pi there. Sorry, forgot about that. That's important. Okay, we change the division bar to a multiplication sign. And by doing that, because we changed division to multiplication, we have to flip this fraction upside down. Okay, I'm going to put this 2 pi over 1, just so we have, both of these being fractions. Now, you could do one of two things. You could cross up this 2 on the top with the 2 on bottom, leaving you with just 3 pi over 1, which is 3 pi. Or if you want to multiply across, 2 pi times 3 would be 6 pi. And isn't 6 pi divided by 2? 6 pi divided by 2 would be 3 pi. I think it's easier just to cancel off the 2 on top with the 2 on bottom and leaving you with 3 pi. So our frequency is 3 pi. All right, so let's write out our equation. So y equals, now this is a positive sine curve because from the origin, aren't we going up first? Even though they don't show us any more of the curve, we're still going up first. It's a positive sine curve. Our amplitude is 1. You could put the 1 in front of the word sine if you want, but you don't have to. And then in front of the x, we have to put our frequency, which is 3 pi. And we don't want to forget that x. So this is our equation.